Hello everyone, I'm Frank and welcome to Frank Puzzles, and I just plugged in my microphones. I just remembered. Um, this is today's hard level difficulty puzzle, and it's called Set of Shurikens by Samu Piano. Excuse me. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Killer. Digits may not repeat in a cage and must sum to the number in the top left corner of the cage, if given. So, for example, these 7 cells must add up to 34, and there cannot have repeats. Remember that. These 7, we don't know what they add up to, but they cannot have repeats also. And these 7 must add up to 33, etc., etc. Arrow. Digits along an arrow must sum to the digit in the bulb. So for example, these 2 digits must add up to this one. So therefore, a valid example would be this is 1, this is 3, and that's 4. Because 1 and 3 add up to 4. All coloring in the grid is purely cosmetic, though it might be useful. Okay, so there are some like highlights of the pinks and the blues. And that's it. And so those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so we have, I think they're all 7 cages, 7 cell cages, right? 1, 2, 3, 4, 5, 6, 7. This is also 7. This is also 7. So whatever in these 2 cells, let's color these red, cannot be in the cage, right? And then in addition, they can't be in these 2 because they must see these 2 from regular Sudoku. So they must be in these 2 cages. They also have to be in one of these 2 out of these 3 red cells, right? So it's the same for each of these, right? These blue have to be in these blue, and they have to be 2 out of these 3 cells. These, we're going to make these orange. Cannot be any of these 5. Cannot be these 2, so it must be these 2. And it has to be in one of these cells. 2 out of 3 of those cells. And these green, we're going to make the green, must be here. And it also has to be in this cell. 2 out of 3. So we know the green cells are counted twice in the 34. So are the blue cells, right? That means both of these blue, well, this blue cell has to be in one of these cells. And it cannot be a 7. It could be a 4. And in fact, the 4 has to be one of these 2 cells. This can't be 4. This can't be 4. So the 4 is one of those 4 cells. This can't be 4. This can't be 4. So 4 is one of these 4 cells. So again, the 2 blue cells, actually the 2 green cells must be the same as this circle. So the 2 green cells and the circle doubled is in the 34. So it's at least, we don't know. So 6 cells that add up to 30. So it could be 1, 9, 2, 8, and 3, 7. Or It's 6 cells, right? So 1928 and 37. Um, hmm. Can you have anything else? Is the question. Probably. This has to be 6 through 9 because it has 3 digits that add up to a digit and 3 unique digits that add up to a digit. So it has to have these 2 cells cannot be these ones, so it has to be these 2 specifically. These 2 cells must be these 2. So the blue one of the blue ones has to be one of these, which means it has to be one of those 3. The other one cannot be either of these. It has to be one of these 4. Okay, so let's simplify things. This is red. They are different from these yellow. I'm gonna make this blue. One of the yellows has to be here. The other yellow has to be here. So this is red. And 2 out of the yellows are here. 2 out of the reds are here. The blue has to be one of these 4, and then we don't know about this. Let's just do the ones we know. Well, so we know this green has to be here. It also has to be one of these 2, and it has to be one of these 3. The orange has to be one of these 2, and has to be one of these 3. The blue is the same. It has to be one of those 2, and it has to be one of those 3. The red is the same. It has to be one of those 2, and it has to be one of those 3. In addition, the red has to be one of those 2, and then has to be one of those 3. The blue has to be one of these 2, and has to be one of those 3. The orange has to be one of those 2, and one of those 3. The green has to also be one of those 3. We know the red and the blue are different. We know the blue and the orange are different. We don't know if the red and the orange are different, though. So we have 6 digits that add up to 30. What are the possibilities? 192837 is the first one that comes to mind. But I guess 1 7 could add up to 2 8, or 2 7 could add up to 9. Hmm. What other possibilities are there? Can you have 5 6 7 8? 1 3 5 6 7 8 works, right? Um, hmm. Is that it? Maybe. 1 3 5 6 7 8. That's 4 plus 13 plus 13. Okay, so what are the, okay. 1, 2, and 3. So the ones with 1, 2, and 3 specifically are 7, 8, and 9. That's the only one that works with that. So if you leave out 1, say you had 2, 3, that's 5. You cannot have anything less than 5, 6, 7, 8. So 2, 3 does not work. 1, 3 does work, and you have 5, 6, 7, 8 as a possibility. You could also have 1, 2, and then you have 4 digits adding up to 27, which would be 5, 6, 7, 9. So the possibilities are 1, 2, 3, 7, 8, 9, 1, 3, 5, 6, 7, 8, and 1, 2, um, 5, 6, 7, 9. Yeah. So the possibilities are you have 1, 2, 3, 7, 8, 9. You have, so that adds up to 30. You have 1, 3, 5, 6, 7, 8. That's 5 and 8 is 13. 6 and 7 is 13 plus 4 would be 30. You also have 1, 2, 5, 6, 7, 9. So you know that 1 and 7 always has to be in the 34s. Right? So this cannot be 7. This can't be 7, obviously. So both of these, see both of these. Or, sorry, one of these is here. The other one is here. So the 7 and the 1. Okay. Let me just, okay, let's clear this. So the possibilities for the 34s are 1, 2, 3, 7, 8, 9. And 1, 2, no, 1, well, I guess we could do it that way. 1, 2, 5, 6, 7, 9. And 1, 2, 1, 3, 5, 6, 7, 8. Right? So you always have a 1 and a 7 in the 34s. So this would see 1 and 7, so it could not be 1 and 7. It has to be 2, 3, no 4, 5, 6, no 7, 8, or 9. So whatever these two cells are the same as these two, which have to be some of these three. If it's 1, 3, 5, 6, 7, what are the two that can add up to the other one, right? So you could have, this could even be 3. If this is 3, this could be 1, 2. Um, Oh, and you could have well, this can't be 4 specifically. But this could contain a 4. We know the 4 is one of these two. So that also has a 4. Which means it could be 1, 2, 3, 6, 8, 9 for the 33. And then 2, 3. It cannot be 5, 6, 7, 8. So it'd be 1, 2, 5, 6, 7, 8. I think those are the only possibilities then? Is that right? 33 with a 4. It always has a 4. So 1, 2. Oh, so this is always 4, which means this can't be 4. This can't be 4. Therefore, this always has a 4 also. This could be part of the 4 here. We just don't know. One of these is 4. One of these is 4. One of these 5 is 4. So 29 from 6 cells. You can have 1, 2, 3, obviously, and that goes with 6, 8, and 9. You could have 1, 2, 5, 6, 7, 8, but can you have 1, 3? No, because 5, 6, 7, 8 is the lowest. So 1, 2, 3 is always with 6, 8, 9. 1, 2, 5 can only be with 6, 7, 8. So this cannot be 1 or 6. So this is 2, 3. No 4. Could be 5. No 6, 7, 8. No 8. 2, 3, 5, 7, or 9 is there. Because that sees all of these. This can't be... This can't be... it's this one. This one can't be 1 or 7. So it has to be 2, 3, no 4, 5, 6, 8, or 9. Also. So this could be 3 and 1, 2. This is 1 through 6. So this can't be 4. This cannot be 1, well, it could be 1, 2, 3, and that's 6. Could even be 4. Huh. I'm gonna pause. I need to go bathroom. And I'm back. Okay, let's continue. This obviously, well, okay. We're not trying to solve the middle part at all. We're trying to figure out what this is. So if this is a 4, that means both of these are the orange, which means they have to be those and have to be those. 1, 2, 3, 7, 8, 9. So this could be 1, 2, and 3. This could be 1, 7, and 8. Or 2, 7, and 9. This could be also 1, 5, and 6. 2, 5, and 7. Or 2, 7, and 9 again. Oh, this can't. Okay, this can't be green. We know that for certain, right? Because it's a 4. So these two. Oh, these two have to equal these two, which must equal these two, right? Because it can't be 4. That can't be. This can't be 4 because of that. These can't be 4 because of that. So therefore, these can't be 4. So there, yeah, these. Okay, so let's remove all the coloring that we have right now. Let's just start with the greens. And let's delete these. So these two must be the same as these two, which must be the same as those two, right? We also know that it cannot have a 1 or a 6 there. So, again, so if it's 1, 2, 3, 7, 8, 9, 1, 2 can add up to 3. 1, 7 can add up to 8. 2, 7 can add up to 9. If it's 1, 2, 5, 6, 7, 9, 1, 5 can add up to 6. 2, 5 can add up to 7. 1, 6 can add up to 7. Or 2, 7 can add up to 9. If it's 1, 3, 5, 6, 7, 8, 1, 5 can add up to 6. 1, 7 can add up to 8. And 3, 5 can add up to 8. So this could be 3 here. So this is 1, 2, 3, 5, and 7. This can't be 9. So this is 1, 2, 3, 5, and 7. Right, because these two arrows, the two ones on the arrow have to be non-9. So this can't be 9 either. So this can't be 9. Because these two are on arrows. These two must equal these two, so it has to be 1 through 6. So this can't be 4. This cell can't be on the arrow, cannot be seen in the cage, cannot be seeing that because of Sudoku, so it must be one of these 3. In addition, it cannot be one of these 2 because it's in the cage, therefore it has to be this one. That's interesting. So this one cannot be here, cannot see these. It could be part of this one, but it would have to be 6 through 9. So the red can be any of these 4. And the red can be any of these 5. Right? So the red is 6, 7, 8, 9. So this has to be 6, 7. This cannot be 4 then. So this is 6, 7, 8, 9. Interesting. Okay, so if the 33 is 1, 2, 5, 6, 7, 8. with 4, obviously. 1, 2, 4, 5, 6, 7, 8. Um, that means this cannot be 2, 5, or 7. So this has to be 3 then, which would make this 3, 5. This would have to be 3 and 5, and this would be 8. So you may, again, make these 3 and 5. So you have 8, so therefore this would be 1, 6, and 7. Means that's 2 and 9. So this is 1, 2, 1, 2, 4, 5, 5, 6, 7, 8, right? So 6, 7, 8. So the 5 is here, and then something else is here, which means this is the 9. Which means this could not be... Okay, this can't be 4. Can't be 1, 6, and 7. This can't be 3, 5, or 8, or 6. So this would have to be the 8. Which means that can't be 8. This can't be 8. This can't be 8. This can't be 9. Therefore, what is this? This can't be 8. It would have to be the other 2. So 4 can't be here. 4 can't be here. 4 can't be here. This obviously can't be 1 or 2. 7 can't obviously be there because these two would have to be add up to it. So this can't be 7. You would have to have 1, 6 or 2, 4, and it can't be 2, 4. So this has to be 1, 6. This would be 7. These can't be 7. So we had 5. This can't be 1 or 6. So this is 2 or 5. That can't be 2. This can't be 2. This would have to be a 2. So this can't be 2, 5. This would be 2, 9, 2, 9. This would be 1 or 6. This would be 1, 6, or 7. This would be 9. Oh, and we have a conflict. Because this would have to be 2, and therefore this would have to be 2. Therefore, we've shown this cannot be the 1, 2, 5, 6, 7, 8. So it has to be 1, 2, 3, 6, 8, 9. So this has to be 1, 2, 3, 6, 8, 9, and the 4 is here. So obviously this can't be 1 or 2. This could be 3, 6, 8, or 9. So this cannot be 2 or 3. Or, yeah, so it has to be 5 and 7 here. Which means this is 5 and 7, which means it cannot be 3. So this has to be 6, 7, 8, or 9. 5 or 7 with it. So it could be 1, 2, or 3. So therefore, this can't be 3, because if this was 3, this would have to be 1 and 2. And that would eliminate all possibilities here. So this can't be 3. This is either 6, in which case it's 1, 5. 8, in which case it could be 1, 7, or 2, 6, or 3, 5. Hold up. We know it's this one, so it cannot contain a 5. So this cannot be 1 or 5. So it can't be 6. So the 6 is out. If it's 8, it has to be 2 and 6. If it's 9, because it can't be 1, 7, because there's no 7, it cannot contain a 4. If it's 9, it has to be 3, 6, or 1, 8. So, yeah. So this is 8 or 9. This has to have a 5 or 7. So it could be 1, 5 to form 6. It could be 2, 5 to form 7. It could be 3, 5 to form 8, and it could be 2, 7 to form 9, or 1, 7 to form 9. So this also sees all of the numbers, and it's 5 or 7 too. So this can't be 5 or 7. This is 1, 2, 3, no 4, 6, 8, 9. So this is 5, 7, 5, 7, which means this cannot be 5. Which means this... These two out of these 3 have to be here. And then they have to be here. So it adds up to 8 or adds up to 9. We don't know which. Oh. So this must contain 5 and 7, right? Wherever this is has to be here and has to be here, right? Whatever this is cannot be here. That's not true. That's not true. So this can't be 7. This is 1, 2, 3, 4. But no 4 here. 6, 8, 9. 1, 2, 3, 6, 8, 9. Mm-hmm. Hmm. Hmm. So again, if this is 8, this has to be 2 and 6. That's interesting. If it's 9, it's 1 and 8, or it's 3 and 6. Hmm. Hmm. So let's try this as 8. If this is 8, this has to be 2 and 6. Cannot be 1, 7. Because there's no 7 in the digits in this set of cage of 33. Can't be 3, 5 because of the same problem. So therefore, this would have to be 2 and 6. Which means this can't be 6 or 8. These can't be 2 or 6. Therefore, these have to be 2 or 6. So this can't be 2 or 6. This can't be 2. This can't be 8. This can't be 8. None of these can be 8. This can't be 6 anymore. So this is 1 of 1, 3, or 9. This can't be 8, so it can't be 1, 7. It can't be 2, 7, so the 7 can't be here. Therefore, this would have to be 5. And it's 5 with either 1. It would have to be 1 and 5. So this would be 6. This would be 1. So 1 would not be here. So this couldn't be 1. This can't be 6. So this would have to be 1 and 5. With 6. So 7 would have to be one of these 3. So this can't be 5. This can't be 6. 7's one of these 3. And it has to be with 2, 9 or 3, 8. Right? This can't be 6. Therefore, and this can't be 6. Therefore, right, we knew that already. So similar to okay. Similarly to knowing that this 8 cannot be here and cannot be here. It has to be here. It can't be here, so it has to be here. So this one, we're going to make it, I don't know, pink. Pink cannot be, has to be here. It has to be here. So this cannot be 1, 2, or 3. What's going on? Why are these squares tang? What is going on? Anyways. Oh, I think I clicked on the wrong button. So this has to be pink, which means this cannot be 1, 2, or 3. It's 6, 8, or 9. This cannot be here, cannot be here, cannot be here, but it could be here. So we don't know about that one. This one can't be this because of the 4. This one can't be this. I mean, this one can't be, this one can't be here, obviously, and can't be the 4. This one can't be any of these. So in this one because of Sudoku, and this one because of the cage. So it has to be here and then here. The pink can't be the 4 because it's not 4. Um, so we made this 8. That seemed to work okay. This would be 2 and 6. This can't be 2. No 2 and 6, no 8. No 8 here. This can't be 8, which means, and this can't be 2. So if it can't be 1 and 7, and therefore the 7's out. So therefore this has to be 5, this has to be 7. And if we try to make it 5, 3, that doesn't work, so therefore this is 5, 1. So this can't be 1, this can't be 1, this can't be 1. This can't be 2 or 6. It has to be, this can't be 8. So it's 1 with 3 or 9. So this has to be 1 and 5. This has to be 1 and 5. So this is 6. So the last one then is 7 with 2, 9, or 3, 8. And this can't be 6. So therefore this has to be the 6. So this has to be either 2, 9 or 3, 8. Right? So this is also 2, 3, 8, 9. 7 can't be here. 7 could be here though. Oh, interesting. Because this is only 2, 3, 8, and 9, if that's the case, this has to be 2 and 3. So this is 2 and 3, which makes this 5, which means this can't be 2 or 3. So this can't be 2 or 3. This is 8 or 9. This can't be 2 or 3. This is 7, 8, and 9. So one of 2 or 3 is here. This can't be 8. So 8 is one of these two, which means this can't be 8. This is 5, so this can't be 5, which means these can't be 5. This can't be the red anymore. This can't be red anymore. Therefore, this is red. This is red. So this has to be 7, which means this is 7, which means this is 7. So this is 1, 2, and 4. So this can't be 4. This can't be 4. This is 3 and 6 with 1, 2, 4. Therefore, this can't be 2. This has to have a 7 then, which we already knew. This can't be 2, therefore it's 1. So this can't be 1, this can't be 1. 1 has to be one of those two. This is 8 or 9. This is 8 or 9. This can't be 7, therefore this must be not. This can't be... Why can't that be 8? That should be able to be 8. Okay, so this can't be... How did we know that was 7? It could be 8 or 9. Oh, because it had to... Red couldn't be this one. Right, red couldn't be any of these three, therefore red had to be one of those two. And the only one that fit would be 7. Right. So this is 2, 9, and 3, 8. Therefore, this is 7. This is 2 and 3, 2 and 3. This can't be 5. Therefore, this has to be 5. which makes this not 5. So this is 1, this is 5. 5, not 2. This can't be 2, so this is 4, this is 2, which makes this 1 and 4. So we have 1 and 4 here. This can't be 1. This is 1, therefore this can't be 1. It can't be 2 and 6. This can't be 1. So this 1 has to be... Okay, this can't be 4. Therefore, this is 4 and 5. This has to be 1, and it has to be the other 8, 9. So this is 4, 5, 6. This has to be 9 and 8. Which means this can't be 3, 8. So this is 2, 9, which makes this 3 and this 2. So far it's looking fine. This can't be 2, therefore this is 2. So that's 2 and 6. So these two are 2 and 6, which means these two are 2 and 6. So this is 6, this is 2. So there's no 6, so it's 1, 2, 3, 7, 8, 9. But the 2 is no longer here. So we've gone and shown that 8 does not work. That was really convoluted. I don't know if I like that way of doing that. Anyways, so the 8 cannot work. So it's either 1, 8, and so 9 is either 3, 8, or 1. Okay. So this has to be 9, which means none of these are 9. So this is 6 or 8. It cannot be 7 or 9. This is 6 or 8. This has to be 1, 8, or 3, 6. So this can't be 9, which means 6 is not allowed. This can't be red. If this was red, it would be equal to that, which would have to be 7, and that's not possible. So this can't be red. This is pink, which is the same as that one. So red could be here, and that would be 7. Or red could be one of these 3. This can't be 9. This cannot be 9. So we could try 1, 8, and we could try 3, 6, right? Actually, can this even work for 5, period? Let's try 1, 5 again. And the 2 can't be here, right? If you tried to have 2, it doesn't work because it has to be 6 or 8. And that's an even, so you have to have odd with odd. Therefore, 2 cannot be here. So it's either 1, 7, and 8, which could be either of these, or 3, 5, and 8, which could be that one, or 1, 5, and 6, which would be either of these two. So we're trying, I think what might be the case is that we have, this is 1, 5, so therefore this is 7. This has to be 1, I think this is the same thing either way. Whoops. This can't be 3 and 7, so this can't be 5. This has to be 6. So we have 13, 17, plus 6 is 23. Therefore, this is 11, so it's 2, 9, or 3, 8. So this is 2, 9, or 3, 8. This has to be 6 then. None of these can be 6. This can't be 6. This can't be 6. This can't be 1. So this is 3, 6. So no 3, no 6. This can't be 1. This can't be 1. This can't be 1. So 1 is here. 1 can't be here. 1 can't be here. 1 can't be here. Okay, so this can't be 6. This is 2, 3, 8, or 9. This is 2, 3, 8, or 9. You can't have 2 with 8 or 3 with 8 or 9. So therefore this has to be 2 and 3, which forces this to be 5. This is 7, this is 7, so therefore this would have to be 7, which means this is 7, so this is 1, 2, 4. So this is 1, 2, 4. Again, so this can't be 4. This has to be 1, 2, 4 to match this, so this can't be 2. Can't be 4, so this is 1. This can't be 1, this can't be 1. This has to be 2 and 3 again. This can't be 2 or 3. This is 8 and 9. This can't be 9, so this is 8, this is 9. Which makes this, yeah, 2, 3, 2, 3. This can't be 2. This is 4, which is 2. This is 1, this is 4. This can't be 2. It cannot be 2. Oh. Well, yeah, we already knew that anyways. Let's see. This can't be 3, and this can't be 6. So 3 is one of these two. This can't be 3. This has to be 3 and 6. Which means one of them has 3 or 6. So this can't be 3 or 6. This has to be 7. So it cannot be 1, 3, 5, 6, 7, 8. Because that requires both 3 and 6. So it have to be has a 2. So this can't be 2. Therefore, we know 2 has to be one of these two. We know there's a 2 here, so this cannot be 2 then. We have 3, 6, 3, 6, 9. This seems okay though right now. This can't be 5. This can't be 5. So this must be 5. This can't be 4. So this must be 4 and 5. Which means this can't be 5. This is 1. This has to be 5. This has to be 3 and 8. This has to be 7. So far, this one looks okay. So this has to be 2 with 3 or 6 here. This has to be 2 and 1 specifically, right? And this can't be 1, so this has to be 2. This would have to be 1. So none of these could be 2. So we have 1, 2, 4, 7. So it's either 3, 8. So we have a 9. 1, 2, 4, 7, 9. So that's 10 plus 13, 23. Yeah, 3, 8, or it's 5, 6. We don't know which. So this can't be 3 or 6, so this is 5 or 8. This is 1 and 8, so it has to be 8. This can't be 8, so this is 4. This is 9. This has to be 3, 2 and 3. This has to be 2 and 3. So this has to be 2, which makes this a 3, which makes this a 2, which makes this a 3, that's a 2. This might actually be a solve. This cannot be 8, so therefore this is 5. This can't be 5 anymore. So this can't be 3 and 8. So this becomes 6, 9, which makes this a 3, which makes this a 6, and this a 8. So this is 9. This looks like a solve, unfortunately. What happens if we make it 1, 8? Does it break? Then that's what we're trying. Can this ever be 1, 7? If this is 1, 7, this has to be 8, obviously. This would be 8. This has to be 3 and 6. Therefore, this would be 3 and 6. And this would be 3 and 6. So, this would have to be 4. This would have to be 1 and 2. So this would have to be 2. This would be 5. This would be 1 and 7. They all have 1 and 7. This can't be 8 here. Oh, it's 8 too. So 1, 7, 8, they have to have a 3. So then this, okay, so this could not be 2 or 1. This can't be 4. So it becomes 3, 6, 8, 9. This can't be 3 or 6. This can't be 6. So this is 7, 8, 7 and 8. This becomes, so this is 2, 3, 5, 6, 9. This is 2, 3, 5, 6, 9. So this can't be 9. This is 2, 3, 5, 6, 9. So this can't be 9. So this is 2, 3, 5, and 6. We know the 3 is here because it's 1 and 7 with 4 and 8. So 1, 7, 4, 8 must have 2, 3, 9 or 3, 5, 6. Which means 3 cannot be here. This can't be 9. 3 and 6 could be here. But it would have to be 3 here and 6 here. Which would mean this is 2, 5, 9, which is possible. Say this was 9, right? That eliminates all 9s from here. So this can never be 9. So if this is 3, if this includes 6, it would have to be 6 and 2. Right? Sorry. If it includes a 6, it's 3 and 6 or 2 and 6. So 7 can't be here anymore. So this is out. So whatever is here has to be one of these 3. So it cannot be 8. So this can't be 8. But then it can't be 7 either because the 7 is here. So this is already shown to be incorrect. So 7 can never be here. Interesting. And yeah, again, the reasoning is because if this is 7, this has to be 7, which means this has to be 7. The red, we know, is one of these 4. It can't be this one because of Sudoku. It can't be this one because of the cage. So it has to be one of these 4. If the 7 is here, it obviously has to be one of these 3. And therefore, it can't be this 7. It would have to be some combination of this. But it can't be, this can't have a 6 because of the 1 making this 3, 6. And this having a 7. It can't be 7 because this no longer applies because this can't be 7 here. So this has to be 8, which would mean this is 8, which would mean this is 8, but then there's no place for 8 in row 8. So the 7 does not work. So therefore, it has to be 5 there. Now, we just don't know if it's... So it's 5 with 1 or 3. We're not sure which. And we tried 6, and that looked like it worked. So the question is, what happens if we try 3, 5? right? So this is 5 and this is 7. So this can never be 7. So 7 could be here and then this one. So this is 5, this is 5, so this can't be 5. So this has to have a 5, which means it cannot be 1, 2, 3, 7, 8, 9. So it has to be 1 or 3 here. If it's 3, 5, okay, let's try this being 3, 5. If this is 3, 5, that means this is 3, 5, 8, which means this is 3, 5. This is also 8. This has to be 1, 6, and 7, right? This can't be 8. This can't be 3 or 6, so therefore this is 8. So this is 6 or 7. This is 6 or 7. This can't be 3. Can't be 6. This is 2 and 9. This is 2 and 9. So this has to be 1, 6, and 7, but no 7 there. So the 6 is potentially still valid, but if it's a 6, it has to be with the 2. So this can't... Okay, these two have to be here. Because it sees all of these 7 squares. So this cannot be 9. This has to be 2. It could be 2 and 1, but this is 9. This can't be the red anymore. These two can't be red. So this one has to be red. Okay, this can't be 1 and 8. This can't be 1 or 8. This can't be 1 or 8. Obviously, this can't be 8. This can't be 8. This can't be 1. This can't be 3 here. This can't be 3. This can't be 3. Therefore, this is 3 with 2 or 6. We don't know which. This is 2. It cannot be with 6 because then this 2 would add up to 8. So therefore, this would have to be 1. Which means this can't be 1, which means that's 1. So this can't be 1, this can't be 1. We have a 6, 7, 6, 7. This can't be red anymore. So since that can't be red, this has to be the red, which means this is 7. So either way we go, this has to be 7. Interesting. So this is 7, this is 6. So this is 2, 4. This is 6. This cannot be 2. This is 2, 3, 6. So no 3, 6 here. This has to be 1, 2, 4 again. So this can't be 4. This is 1, 2, or 4. This has to be 1 and 2. If that's the case, then this is 3. So therefore, this is 4. This can't be 1 or 2, and therefore this is 4. So we have a contradiction here. These both have to be 4 and 1 and 2. So therefore, it cannot be 3 and 5. Therefore, we know that the path that we were going down is correct. So therefore, it has to be 1 and 5 that add up to it. So that was very convoluted. So we know it's 5, and we know now it's 1 with it. So this has to be 1, which makes this 3 and 6. This is 1, 3, 1, 5, which adds up to 6. This has to be 1 and 5. This can't be 6 anymore. This has to be a 6. So these can't be 1 or 6. This can't be 1 or 6. This can't be 1 or 6. The 1 is here, so the 1 cannot be here. This can't be 6. This is 7 or 8. So this is 7 or 8. This has to be 7 with 2, 9, or 3, 8. If it's not 7, it just doesn't add up, right? You have 1, 4, 5, and 6. That adds up to 16. 34 minus 16 is 18, and you can only have 2, 7, 9, or 3, 7, 8 that add up from the remaining digits. Therefore, this is 2, 3, 8, 9. This can't be 7, so this is also 2, 3, 8, 9. And again, 2 cannot add up with 8 or 9. 3 can't add up with 8 or 9 to form a single digit. And we know these two have to be these two. So because of that, okay, we also know this, yeah. So these cannot be 8 and 9 because they don't add up to a digit, because these two specifically have to be these two, right? Because these two see all of these cells, and the only two in box 8 it doesn't see are these two cells. Therefore, this has to be 2 and 3. Therefore, this cannot be 2 and 3. This can't be 2 and 3. This can't be 2 and 3. These can't be red anymore. And because these can't be red, the only red possible is this cell. So these can't be red then, and therefore this is the red in row 7. So this has to be 7. This is 7. This is 7. This can't be 3. This can't be 3 or 6. This is 8 or 9. This has to be 2 and 3, which adds up to 5. Therefore, this is 1, 2, and 4. And because of the properties here, we know that these two must be the same as those two. So it's 1, 2, and 4 here. This can't be 2. This can't be 2. So it's 1 and 4. That can't be 4. This is 1. This is 4. This has to be the 2, which makes this 1, this 4. These can't be 4 anymore. These can't be 4 anymore. So this is 8 or 9. This is 8 or 9. This can't be 2. This has a 7. Oh, wait, we need to have 1, 2, 3, 7, 8, 9 still. Let's see. This is, so this can't be 9, therefore this is 8. This is 9, which makes this 3, 7, 8. So this can't be 3. This is 2, therefore this is 3. This can't be 3, therefore this has to be the 3. That's 3 in the corner. This has to be a 7 because of this 7, so therefore this is 7. This, we know 1 and 4 are here. So 4 is here, therefore this must be 1. It must contain a 1 and a 4. 1 of 3 or 6 is one of these 3. This cannot have 3, 6, and 8. And because it can't have 3, 6, and 8, 1, 3, 5, 6, 7, 8 is eliminated. Therefore, it must contain a 2 from one of these two. Therefore, this has to be a 2 because that's the only possibility. This can't be 2 now. This is 2. So it's 1, 2, 4, 7. So it's either 3, 8, 9 or it's 5, 6, 9. So 3, 8, 9 or 5, 6, 9. Which means if this is 5, 6, 9, this has to be 3, 8, 3, 8. If it's 5, 6, 9, if it's 3, 8, 9, this is 6 and this is 5. But this can't be 3 here. We also know, yeah, this is 3 and 6. This has to be the same as 3 and 6. So this is 3 and 6. This can't be 9 here. And it can't be 3 or 6. So it's 5, 8, 5, 8. This has to be in the 9. Now, this has to be 1 and 8. Because it can't be 2. So this is 8. Because this one has to be one of those. So therefore, this is 8. Which makes this 5. So we now have 1, 2, 4, 5. And it has to be 6 and 9. So this is 6 and 9. Which makes this a 3. Which makes this a 6. This has to be 8. This can't be 8 anymore. This can't be 2. So this is 4. This is 2. This can't be 2, 4, or 8. So this is 9. And we have all the 34, so we don't need those numbers anymore. This is 3 or 8. It can't be 3 or 8. It can't be 3 here, so this is 8. This is 3. This has to be 2, 6, and 9. This can't be 2. This can't be 8, so this is 9, which means that can't be 9, so that's 8. This can't be 5, so this has to be 5, which makes this a 1, which makes this a 5. So the 1 has to be one of these. And it has to be 1 and 9, because it has to be these two digits. So therefore, this is 6. This is 4, 5, and 6. This has to be 3. So then this is, that's another 3 in the corner we celebrate. That's 5, 7, and 8 here. This can't be 7, obviously. This can't be 9. It can't be 2 or 3, so this is 4, 5, 6, 7, 8. This can't be 3, so this has to be 8. This has to be 3, so this can't be 8 anymore. So it could be 4, but that would require 1, 3, so it can't be 4. If it's 5, it would require 1, 4, or 2, 3, but it can't be, so therefore it can't be 5. If it's 6, it requires 1, 5, or 2, 4, and that would eliminate any possibility here and here. So therefore it can't be 6, therefore it must be 7. It must have 1 and 6 or 2 and 5. We don't know which. So this can't be 7 or 8, so this is 5, which makes that 1. This is 5. That can't 4. This can't be 2 and 5. This can't be 5, therefore this is 8. This has to be 7. This can't be 1 and 6, so this can't be 6, so this is 9. This is 6. This can't be 6 or 9, so this is 2. This can't be 2 or 6, so this is 9. Therefore that's 6. This can't be 9, so this is 1. This is 9. 2 has to be here, so this is 2, which makes this 3 and that 2. 2 can't be here or here or here or here, so therefore this is 2. Now we have 3 and 5, that can't be 3, so this is 5, this is 3, this has to be a 8. This can't be 5. This is 4, 5, and 7. 5 and 7 are eliminated here, so therefore this is 4, which makes this 6. These can't be 6. This has to be 5 or 7. This can't be 7, so therefore this must be a 5, which means that's 7. That can't be 5 anymore, so that's 4. This can't be 4, so it's a 5. We have 4 and 9. That can't be 4, so this is a 9. This is a 4. 8 can't be here, so this is 1. 8. Now we're just doing Sudoku. We were doing Sudoku for the past, yeah. And that's the solution. Interesting. I liked how the cages interacted with the numbers, and therefore that forced certain digits to be certain positions. Like these had to be on the arrow, and the arrow gave some certain reasoning there. Definitely hard, but very doable. I enjoyed it, and I hope you enjoyed the solve too. And I'll see you next time on Frank Puzzles. Take care.